Lab 2, Motion of the Falling Object by Hanbin Kim. The purpose of the lab was to apply the Newton's second law to a falling object and analyze how weight force and drag force acts upon the system. First, I videotaped the tennis ball falling from my hand, and I used my height as the measurement, 165, which is from my neck. And here's the video. As ball falls down, I placed the center of the mass to gain the data. As you can see, the axes are in negative y direction. Therefore, I'm going to use the t and the y data from the checker. With that, I put it in the spreadsheet. There's the time, and the experimental position was the one I got from the checker. And I calculated the experimental velocity by using the formula v equals final position minus initial position over final time minus the initial time, which is delta p over delta t, which one I got from here. And then I extracted the file. After that, I formed a graph, as you can see in here. But there are two more graphs, which is the experimental ones. So here, there are two motor positions. One is only with the weight force, and the other one is with the drag force and the weight force. And there's two velocity, weight force and drag force and the weight force. I calculated the motor position of the weight force by first calculating the motor velocity using the Newton's second law, where the F net is weight force for the motor velocity 1, and F net is weight force and drag force for the motor velocity 2. The formula for the weight force and the drag force are shown here. Negative b times velocity, and weight is negative mg, g which is the gravity of the earth. And here is the Python file. So first of all, this is weight force and the drag force together. The force mass is 0.057, and velocity and position, as you can see, is right here. And the delta t I got from the file, and gravity is 9.8. J hat is in y direction. B I calculated, and then there is the file. T is in 0.5 seconds, and there's weight force, there's drag force. I added together to get the net force, and it's force velocity, Newton's second law, and force position. And this is the Python file. As you can see, this yellow arrow is the weight force, and this blue arrow is the drag force, which contrast each other because weight force pulls down while drag force slows you down. So the other one is the weight force only. It looks similar, but there isn't like additional force acted upon it. So with that in mind, I formed a graph. First of all, position versus time graph. As you can see, the blue is the experimental position, and model position are red and orange. They contrast different a lot because there is more force acted upon the experimental position, in my opinion. The drag force and weight force graph doesn't change much because I think I videotaped the file inside my house, and the distance that the ball fell was such a short amount. The drag force didn't act upon the ball much. Therefore, it slowed it down just a little bit. While in the experimental position, as you can see, it is dramatically different than what I calculated, because in reality, I could have dropped the ball, not just in y direction. As you can see, the ball curves a bit, and I could have like put some more force in the ball, and therefore the graph differs. And as you can see in the velocity graph, the velocity changed dramatically in my experimental position, while in the model position it accelerates constantly. It slows down and speeds up because of like experimental errors. Therefore, in my opinion, the drag force doesn't act a lot as much if the ball is falling a little distance. If ball is falling from the high distance, and if it is in bigger like shape or volume, then drag force will act upon the system much more than just a tennis ball or a small mass or small system. Thank you.